Welcome to Chem Help ASAP. Let's discuss lab reports for an organic experiment. I don't like starting videos with a disclaimer, but I think it's important in this case. I'm going to outline the way I teach my students to write a formal lab report. Many instructors do not use formal lab reports. Even if they do, their expectations will likely be different than mine. Always look to your instructor for guidelines on how the document should be prepared, your lab report. I'll start with some of my thoughts for assigning formal lab reports in organic chemistry. First, writing a formal lab report, modeled after a research paper, teaches what material belongs where in a paper. Many organic students will need to read scientific papers in the future, and it's worthwhile to understand how and why content is organized. Second, students learn about scientific writing, which is decidedly different from other writing styles that are encountered more frequently in undergraduate classes. In a single word, concise. Students are encouraged to be concise in their communication. That has two benefits. One, I think it's representative of scientific writing, and two, it's less material to read and grade. Here's how this formal lab report works. First, the student works through an experiment, start to finish. The experiment ends with a yield of a product and characterization data. Second, the student will take the information from the lab and populate the different parts of a paper in a template file. Third, students will add more features like graphics and references to complete the report. As a final comment here, a single experiment in a teaching lab is not worthy of writing a full research paper. That's okay. We can still use the model of a research paper to structure the report while learning how papers are assembled. Our paper will be shorter than a real research article, but we can still learn through the exercise. Here are the common parts of a research paper. We have title, authors and affiliations, abstract, introduction, results, discussion, experimental, and references. The sections in ordering that I am listing are for a typical organic chemistry paper. Other disciplines, even other fields within chemistry, are often different. Let's go through what belongs in each section. Title and authors are easy. The title is the title. Be short but somewhat descriptive. For example, aldol condensation of a ketone and aldehyde. Nothing fancy. The author listing should include anyone in your group. I have groups of one in my classes, so my students list just one author. The affiliation is your institution. My students list Davidson College along with Davidson's location. Listing email information, contact information is also common. The abstract is confusing for many students. The abstract is not a summary of the full paper. Instead, the abstract is a summary of your major findings. For a synthetic experiment, your major finding is the reaction yield and structural conformation. For these formal lab reports, 1 or 2 sentences suffice. The introduction is also somewhat confusing. The introduction provides your motivation for the work you are doing. Your motivation is normally the work of other people, so the introduction covers other people's work and requires references to other people's work. Do not describe what you did. Your introduction should also conclude with a single sentence that reads something like, "Because X is so important, we decided to do Y." This sentence is a transition. It announces to the reader that you are transitioning from the introduction, which is what other people have done, to the next section, the results and discussion, which is what you did. Results and discussion. These are 2 separate sections, but they are often combined, and we will also combine them. Your results are your outcomes. Note that these are also the items that will appear in your abstract. The major outcomes. The discussion is an analysis of your results. There isn't a lot of analysis for the typical synthetic reaction. You wanted to make something, and you made it. The characterization data provides something to discuss, as in, the data confirmed the expected structure. The experimental section is where you give the full details for the synthetic procedure. For every compound made, you will include a separate procedure. For each procedure, you start with the full IUPAC name of the molecule. This is the only place you will likely use the full name of the molecule. We'll discuss this more in a bit. Along with the full name and its number, more later, you then give the procedure. This is a challenge because you want to give clear instructions, but you also want to be concise. Key information includes amounts of reagents added, temperatures, length of reactions, steps in the product isolation and purification. Keep in mind, however, you need to be concise. This should be a healthy paragraph. At the end of the paragraph should be all the characterization data. Items like melting point, TLC data, and NMR peak information. There is a style to reporting these data, so use the model lab report as a guide for how data should be reported. Literature references should follow the American Chemical Society, ACS, style. I won't give every type of document, but these are the common types of references that you will likely use. Each reference should be numbered and listed just once and in the order in which it is encountered in the lab report. Citations of references should use a superscript within the text. Again, follow the lead of the sample lab report. Every lab report should have at least 3 references. You'll need at least one for your introduction because you are citing other people's work. You should cite the lab handout as your procedure in both the results section and maybe the experimental. Since you access the lab handout page as a web page, cite the handout as a web page. Finally, the products for these reactions are literature compounds, so cite the reference for the literature melting point in the experimental section. Fantastic. Those are the basics. Now let's try to reinforce some ideas. I love the cooking parallel for chemical reactions, so let's see that in the context of a lab report. Is it possible to fit a recipe or article on a recipe as a science article? Sure. Let's say we were looking at a recipe for easy bake brownies. That's our title. Okay, well, somebody wrote the article, so there's our author. The abstract might be a subtitle. Brownies in 15 minutes. That's great. That's the major result. The introduction reveals the motivation. For this recipe, it might be guests are coming over and you need a dessert fast. That is a motivation. The recipe model kind of falls apart now. The rest of the recipe will be more like the experimental, the ingredients, and the procedure. Still, lots of an article on a recipe does fit within the framework of a scientific article. Now let's drop the recipe idea and say we want to make a molecule that might have anti-cancer activity. What would that look like? I'll just focus on the introduction. We want to provide our motivation and the work of others. The introduction might mention the fact that cancer causes a lot of deaths, and you would cite the World Health Organization. That's your motivation. And then you might say, other people have made cancer drugs, and so that would be the work of others. And that would lead to a nice transition. Since cancer is a problem, here are our efforts to solve this problem. And there's your transition, and now you're ready to talk about your results and discussion. There is one more important idea that we haven't discussed. That is the inclusion of chemical structures in our document. To do this, we'll use a program called ChemDraw. Many universities have licenses to provide students with free access to ChemDraw. ChemDraw is essentially an art program that allows one to quickly draw molecules. Here is the opening screen for ChemDraw. We have a drawing space in the middle of the screen and a set of tools on the left. Now, before we begin, go in File and Apply Settings From, and then go ACS Document. That'll give our structures a nice appearance. Now, to begin, we can draw things. We can draw things like rings by clicking on a tool. And we can click there. We can erase things by clicking on the eraser. Whoops. You got to click on the bond. It doesn't like it if you don't click on the bond. So that's great. We can draw a different ring. Let's go 5-membered ring. Now, if you get tired of using the eraser, Control-Z will always undo things like drawing a ring. Now, let's get a benzene ring on the screen. Now, what can we do with this? We can lasso it. So we get the lasso. We've selected it. And now we can do a quick copy either through the menu or Control-C. Now let's go to Word. And here's our introduction. And we can paste in our structure. Bam! So there's our structure in our document. As an image of a molecule, we would call this a figure. Figure 1. And if you put a figure in a document, you want to give that a call out. So I like benzene, figure 1. And so now we have a call out to our figure and something in our figure. Okay, that's great. So let's jump back into ChemDraw. And now let's do a reaction. We want to make benzene, and we're going to react this and make bromobenzene. So we can add a bond to our benzene ring, and we can put a label on the end of that bond. That's Br. Now we need a reaction arrow. No problem. Some text. This is Br2. FeBr3. Let's center that. And now look, everything's all over the place. So let's just try, we can use the lasso tool and we can move things around so they're a little prettier and a little more lined up. Okay, that's good enough for our purposes. Now, let's take this full reaction, copy this, go back into Word, and let's place our reaction. Now, this is not a figure, it's not a single thing, we're actually showing a transformation. That is a scheme. And of course, we need a call out for our scheme. Benzene does reactions. And that would be scheme 1. So now we have a call out for our scheme and something in our scheme. So this is fantastic. So a couple more quick ideas. Generally, in lab reports, molecules get numbered. So let's go back to ChemDraw, and benzene, I'll be a little tricky here. Benzene, this is our first molecule. And normally our numbers are bolded. So there's a bold number 1, and let's kind of center that. And now, this is now benzene, it's molecule 1. We'll copy it, go back into here, and I'm just going to delete that. And there, it's benzene 1. I like benzene. Now when we refer to benzene, we can say, oh, that's compound number 1. Let's do the same in our scheme. Switch over here. Bromobenzene is compound 2. Move that down. That doesn't have to be perfect, not for this. So now we'll lasso this, copy, delete, and paste. Benzene does reaction. We can say compound 1 makes compound 2. It's a terrible sentence, but you get the idea. You can refer to compounds by number, so you don't always have to use their name, bromobenzene and such. So this is very important. Now let's do one more thing. Let's do something else with our scheme. I'm going to make this a little wider so it doesn't work so well. Okay, so let's put a third molecule out here. We won't add reagents, but let's say we want to put a methyl group on our benzene ring. Maybe we put an acetyl group out here. Now we can draw bonds. ChemDraw is a great program. I mean, it's so easy to use. It's been around forever. Okay, so there's our structure. Let's say this is structure number 3. Just because we should label all this stuff. Now let's highlight this whole thing and take it into our document. So this will be scheme 2. Now if you notice where our margin is, this is a little bit too big to fit in the margins. And this happens sometimes. Your structure will get too wide for the column of our document. This is a 2-column document. What you can do to fix that, and this is not a terrible example, but sometimes it really gets way too big. You can stack your structures so that you can read this document as, okay, here's a scheme, and now here's the rest of the scheme. And that way, your structures take up a little bit less space horizontally. Delete and paste. Well, it wrapped it up here, but now it definitely fits within the margins of the windows. And of course, this would be scheme 2, and we need a call out for that in the text as well. So those are some of the basics of using ChemDraw in a document. It's a really easy program to use. There is a learning curve to it, but once you figure it out, it's pretty easy. To close, I'd like to walk through a mock lab report. This is a lab report that I wrote for an experiment that I no longer use. Here is the top of the first page. It has a boring title. That's fine. There is an author, there's affiliation with an address, and then email. Now the abstract. It covers all the major result. We made a product, and it has a yield. And the product is confirmed by data. Now you might write an abstract and find that it reads much like this. That's okay. That is not plagiarism. It's using efficient scientific language to communicate a very common idea. Here is the bottom half of the first page. Like many journal articles, it has a 2-column format. The introduction is about what other people have done. This lab experiment is a Diels-Alder reaction. So I say Diels-Alder cycloadditions are classics. That's all you need. The reference is to a review article about Diels-Alder reactions. You could also cite a textbook. You'll always want a figure or scheme in the introduction. This is a scheme. It's labeled as a scheme. It has a call out in the text, and the compounds are all numbered. The last sentence uses first person to announce that we are going from the intro to the results and discussion. Always have this transition sentence. The results and discussion very briefly mentions the reaction. And we have a scheme that goes along with what was done. So if you're going to describe what was done, it's nice to give a picture of what you did. And that's the scheme. That's scheme 2. It has a call out. One point worth mentioning, the amount of detail for the experiment in this section should be minimal. Is it wrong to give a lot of detail? Well, yes, it is wrong. There's a place for a lot of experimental detail, and that is in the experimental section. Here is the second page, and it's just a half page. I have included a conclusion that is completely optional. The real focus here is the experimental section. It starts with the name of a molecule. This is the name of the molecule and its compound number as numbered in the schemes. The experimental procedure very concisely describes how to make the molecule. It includes amounts and times and temperatures, etc. At the end of the experimental is a list of characterization data, TLC, melting point, and NMR. Finally, we get to the references. Reference 1 is cited in the introduction. You can go back and see where we cited that in the introduction section. Now, reference 2 is cited in the experimental section. It is the literature melting point that we cited, so we need to include that reference. Now, one thing I'm missing in this lab report is a citation of the laboratory procedure. So really, the lab handout, that should be reference number 2, and maybe we'd put it over here next to the experimental compound, the compound that we named using that lab handout procedure, and that would make the literature reference number 3. So that's how references work. So while this is a complete discussion of how to do a formal lab report, the first lab report is always the hardest. When in doubt, just follow the model lab report. Once you've done one of these, the next ones are actually very easy. Thank you so much for watching. If you made it all the way to the end, then gold star for you. If you have any questions, please leave them in the comments section. Otherwise, please subscribe, like, or leave a comment. Take care.